Welcome one and all. For those that don't know me, I'm Jim Simpson, the convener for the Climate Realists of Dock. Welcome along, and especially welcome to Wyss Yim, Professor Wyss Yim from
Thank you,
Hong
Jim.
Kong.
Thank you very much. But for what it's worth, the NASA expert on Arctic sea ice is Dr. Claire Parkinson's. I think I mentioned this before. It's a small world. And she thinks we have a good case for submarine volcanoes changing Arctic sea ice extent, as I've spoken about this before. Okay. Now this is my pet subject, sea levels. I am associated with this group called INQUA, International Union for Quaternary Research, for more than 10 years. And they are the people who knows about long-term climate change driving sea level. Sea level is the definitive topic of climate change, if you seriously think about it. Temperature may go up a little bit or go down a little bit, but rainfall also. But sea level is much more important in a way, closely related to climate. Basically, the plan that I'm going to stick to, I'll give a short introduction, then I'll talk about the longer record of sea level change over 500,000 years. Then I'll look at the tide gauge record, which is relatively short, 1954 to the present. Then I'll draw up some conclusions. Next slide, please.
There you go.
Now this is pretty much propaganda, National Geographic, showing a map. If all the ice melt, it may result in a sea level rise of 65 meters. But we know this cannot happen. Next slide, please. If you believe that CO2 is driving it, this is the IPCC story, then by year 2100, we may have up to more than 4 meters of sea level rise. So based on different emission scenarios. Next slide, please. But why is this an oversimplification blaming carbon dioxide? Now you hear about sea level in Hong Kong, and nowhere you can see carbon dioxide is driving it. I think we can look at it now in more detail. Next slide. The background for Hong Kong, unfortunately, some words are missing. On my right-hand side is a satellite image of Hong Kong. We are at the mouth of a delta, the Pearl River Delta, an estuary in part. So it's a highland coast, similar to eastern Australia. So it's been drowned by the Holocene transgression. You can see the delta here, the prograding delta. Hong Kong is here, it's a highland area. That's where our airport is located, Lantau Island, Hong Kong Island, and so on. The main features are, it's a submerged highland, it's a prograding delta with sediment loading. So the delta is prograding into the South China Sea at a rate of at least 50 meters a year. So the loading on the crust through sedimentation. There's new tectonics, so earthquakes in the present day, up to magnitude 6 within 250 kilometers of Hong Kong. Hong Kong area also have earthquakes up to magnitude 4 have been measured, but these are very shallow earthquakes. Man-made reclamations are also loading the crust. There's also groundwater withdrawal in the Pearl River Delta, similar to Bangkok and Venice. But Hong Kong itself doesn't use much groundwater because we rely on reservoirs for water drinking. The datums for sea level is summarized on this chart. Our surveying datum is what is called the principal datum. It's about 15 centimeters above the lowest tide, which is the chart datum. The tidal range in Hong Kong is relatively small, about 2.7 meters. But we do have typhoon-induced storm surges causing much higher sea level, even though these are short-term. For example, during this typhoon in 1937, in Victoria Harbour, a location, North Point, where there is a tide gauge, it shot up 3.9 meters. But in Tidal Harbour, which is located here, so it's surrounded by highland with a narrow exit to the east into Mersey Bay, we have the maximum storm surge of 6.1 meters. And this is entirely driven by the coastal configuration and the wind forcing. Next slide. Hong Kong government has relied on reclaiming land for sale. And through this, they generate income. And through the years, we have many new reclamations, and Hong Kong economy has done quite well. So you see many of these reclaimed areas in Hong Kong. And these are the low-lying areas being threatened by future sea level rise, if you believe in global warming-driven sea level rise. Next slide. Okay. Now, factors affecting sea level after Mona with some modification is summarized in this chart. Coastal dynamics includes erosion, silting up, sediment transport, land runoff, air pressure changes, prevailing wind direction, storms including typhoons and tsunamis. There's also land level changes, compaction, geoid deformation, earthquakes, groundwater extraction, hydroisostasy, sediment isostasy, glacial isostasy, loading and excavation. And sea level changes can also result from glacial eustasy, geoid deformation, steric effect, temperature and salinity, basin volume changes, long-term tectonics and glacial rebound, and so on. So these are all the possible factors contributing to these changes. So I can't go through any in details. There are experts in these individual areas, which is listed. I don't claim to be an expert in all these areas. Next slide. I'll start off looking at the past record of long-term sea level change for the past 500,000 years or 500,000 years. And these are real global climate change because they're driven by interglacial glacial cycles.
It's right there.
Okay, I stand a bit closer. Great. Next slide. Now these are Hong Kong locations. On Ping Chau, which is an island on the eastern side of Hong Kong, we do have cliffs 48 meters high. And we have notches eroded by higher sea level in the past, at least 3 meters above the present. So we can still walk around the island dry without getting wet. And we have wave-cut platform, not as grand as some of your coastal features in the Eastern Australia, but we do have them in exposed locations. And we think these are due to Pleistocene inheritance. This is my friend David Hopley from James Cook University, who is a geomorphologist, has promoted this idea. So many times sea level have came up to roughly about 3 meters or so above present sea level. Do a bit more erosion, and this is why we have all these relic features, coastal erosion features. Next slide. Now we also have lots of information from engineering construction. From building Cross Harbour Tunnel, we do dredging, excavating the seabed to lay down these immersed tube tunnels. And from dredging, we usually get very good specimens. For example, in the top marine layer on the sea bottom, we can have oyster shells, corals, and so on. And they can be radiocarbon dated. And these have given a date of about 7,000 years, more or less proving that the present sea level is not much more than that old, maybe even less, about 6,000 years or so. Next slide. A major construction scheme for the High Island Reservoir for marine dams, we were able to see excavation of the seafloor entirely dry after pumping out the seawater between cofferdams. So you have a view at the bottom. After construction, you can see two dams. The one is on the eastern side, so we just call it the east dam, and then the other one, which you can just about see, is the west dam. The foundation are quite different. At the west dam site, there's a layer of marine mud, which is gray in color. The reason why it's gray is because of pyrite, iron pyrites. And beneath that is an alluvial sequence, basically coarser at the bottom, finding upwards. There are lag deposits of plants, maybe representing swamps. You can see a layer here, this darker layer. We think there are different terrestrial units. They're basically alluvial deposits underneath the marine deposits. So the Holocene-Pleistocene boundary is probably underneath the M1. M1 is the first marine layer. At the east dam site, we find two marine layers. And in the top of the second marine layer, it has a paleodesiccated crust formed by subaerial exposure of the last interglacial marine deposit. We can find shells in the M2 unit, so this is the last interglacial. So for the first time, we have identified a higher sea level older than the present, older than the Holocene. Next slide, please. When we built the island line for the mass transit railway, underneath the central district, underneath all this building, at the Shangwan MTR station, we found an oyster bed underneath the, which we think is M2 layer, the second marine unit. We've radiocarbon dated this. The radiocarbon date is about 30,000 years. We didn't quite believe this date because 30,000 means the sea level 30,000 years ago must have been much higher based on the position of these oyster shells. We decided to try another method of dating using uranium series at Harwell in the UK, and it turned out to be 4 times older. It fitted in as last interglacial in age, so confirming that this is more likely to be the true age. So for the first time, we chuck away any radiocarbon date older than about 8,000. Next slide. We also have lots of drill holes done for engineering construction or proposed projects. This is a typical drill rig, and this is a close-up. And this borehole, which is about 60 meters long, which is continuous, provide information for us to identify at least 5 marine layers, a maximum of 5 marine layers on the seafloor of Hong Kong. Next slide. Between Hong Kong Island and Lantau Island, which is where the airport is located, WB7, what we've done is we've separated some of these samples, so I've laid them out in a row. And basically in the drill hole log, you can see there are 5 layers. M1, first marine layer, second marine layer, M2. We don't have T1 at this location, no alluvial deposit. But T2 is an alluvial unit. We have another marine unit, M3, alluvial unit T3, marine unit M4, so up to 5. And then underneath M5, another terrestrial unit, then on weathered bedrock. So this is in a 60-meter borehole, we can find evidence of 5 interglacial and 5 glacial in the sequence for the first time in Hong Kong. Next slide. So this is our model. Based on the locations of boreholes, we can identify the maximum thickness of these different units. So the marine and terrestrial units, we've labeled them either M1 all the way to M5, T1 to T5, and so on. And just by counting back, we can work out the age based on the global evidence. But we also have local dating to support this information. So M for marine, T for terrestrial. Next slide. So the age determination, we make use of a combination of methods. Very important is the order of marine and terrestrial deposits. If we can find suitable materials to date, radiocarbon can be used if they are reliable, if they are of a younger age, less than about 8,200. The reason why 8,200 is important is the meltwater pulse of the Laurentide meltwater. This is well studied by some scientists. Uranium series dating are useful for dating the older marine units, M2 to M5. Some were done at ANU, Australian National University. We can also use luminescence dating for dating the terrestrial unit. We were lucky, Wollongong actually did some for us, and we published it together. Cosmogenic nuclei can also be used, and this is particularly interesting, that we have major landslides during glacial stages when sea level was much lower. We don't know how low in Hong Kong, but at least around 100 meters or so. We can also correlate with other parts of the world, from ice cores, deep sea cores, and lowest deposits, and I can show this later. We can also use indirect methods like fossils, and very important for the engineers, engineering properties, we can explain it. If you have any seafloor construction, like cross-harbor tunnels and so on, or foundations for reclamations, for development. Next slide. This is one example. Our airport site, I've selected 2 boreholes. The borehole M41 shows the Holocene marine unit resting on top of the last interglacial marine unit, and this rests on top of an alluvial unit T2. So the second last glacial. The particle size is shown in this chart, and the last column shows the iron content. You can see that the M2 unit at the top, the iron content increase. And this is due to subaerial oxidation during exposure of the marine unit during M2 because of acid sulfate soils. These marine units are muddy units, so they contain pyrite. So when subaerially exposed, you have development of acid sulfate soils. And this usually destroys the carbonate shells. So not so easy to find suitable shell samples for uranium series dating. But if you are lucky, deeper down in low permeability area, in silty clays, you stand a chance of finding these suitable samples for uranium series dating. A simple test you can do if you have a continuous borehole like what we have in Hong Kong is to do moisture content measurement. It doesn't cost very much money. All you need is a box, a small fixed volume box, press it into your cores and take continuous samples from top to bottom down your borehole, and you plot it down here. So this is all from the same borehole. You see the M1 the upper marine unit, the uppermost, have the highest water content because it's waterlogged during the Holocene. Then the M2 unit has been subjected to one subaerial exposure. So it decreases, M3 and M4 and so on. So moisture content basically tells you the stratigraphy. Not very expensive, but you just weight the sample before you dry it and weight it afterwards. You've dried it, then you get all these plots. Next slide. So in Hong Kong, we came up with this record as shown in the middle. This is the ice core record from Woodstock. So Hong Kong, we can find M1, M2, M3, M4, M5 marine units, and possible to find T1 to T5 terrestrial unit. Not in all boreholes. Some of them may be missing because the river may not be depositing there during the low stand. So, but we only go as far back as about 500,000 years. But very important, I think, is this lag in the ice core, which a lot of people have pointed out already, of about 800 years. The present day level of CO2 is about 420, much higher than any of these. Okay, next slide, please. Okay, we'll move on to the present tide gauge record. Next slide. We are lucky. We have 7 tide gauges in Hong Kong. So most people only talk about tide gauges from one location and talk about global sea level change already. I don't think you can do that. If you have more information, you must take them into account. Our longest record is in Victoria Harbour, North Point Quarry Bay. It started in 1954. You can read it, it's not so sharp. But the other stations are much shorter. Most of them are only 20, 30 years. So, first of all, the location of all these tide gauges are different. And this is something quite important. People don't talk about this. Next slide. Tide gauges are still well type. Basically, it's a well with damping, so you can take into account the water level when it's relatively stable, without impact of waves and so on. So they are mechanical tide gauges. Some people think they do have errors, but since it's widely used, people just accept that they are useful in providing information on sea level. Next slide. Our North Point tide gauge, which is the oldest one in Hong Kong, is housed in this building. You notice there's a highway seaward of it. So this is the Eastern Harbour Eastern Corridor. So North Point tide gauge was built in 1954. It was moved to a new location in 1986 because of the construction of the Eastern Corridor. The engineers think that it may impact the stability of this tide gauge, so that's why they spent money on moving it. The unfortunate thing is they move it also to a new reclamation, from one reclamation to the other. It's not founded on bedrock. I contacted the engineers in Port Works Department at the time. He apologetically said, we've already decided on the location, so the money's been spent. They cannot ask for more money. But what they did was precise leveling of the new tide gauge to a bedrock benchmark, which was established on the north coast of Hong Kong. So they assumed that the precise leveling can give us information by continuously leveling every year. So I think this may partially correct for ground settlement. Next slide. So it's about 0.5 kilometers away from the North Point tide gauge. So the Hong Kong Observatory, who is responsible for these measurements, said based on their analysis, it doesn't make much difference. And since they are basically along the same coastline, they assume that it can be used continuously, which I question a little bit. Next slide. Okay, the record that they have from these two combined tide gauge, which is the longest out of the 7 in Hong Kong, is shown here. So based on projection, they claim that the rate of sea level rise during this time period, 1954 to 2022, is 32 millimeters per decade, right? So this is similar to the IPCC rate, actually, not very much different. But you can see the record is variable. 1986, we have moved the tide gauge, and there seems to be something funny going on there. Suddenly, dramatic increase, accelerated sea level rise. Now, if we look at this in more detail, next slide. I think you can all see this and maybe agree with me. There are two major pauses in sea level rise. 32 years from about 1959 to 1991, and another pause in sea level rise from 1999 to the present. Right? So there are major pauses in sea level rise. It does not support global warming driving sea level rise continuously. Okay. Next slide. And you can all see this dramatic accelerated sea level rise of 26 centimeters within this period, 1991 to 1999. Right? This is based on the Victoria Harbour 2 tide gauge, North Point, Quarry Bay. Now, what is interesting is, if you read the literature, a retired professor from Florida with Terrestrial has found a 1995 seismicity inflection point. He found, based on his analysis of seismic events on the seafloor all over the world, that 1995 coincided with a time of more active submarine volcanism. And that means heating up the seawater, causing thermal expansion of the oceans. And this seems to fit in very nicely with this accelerated sea level rise, as we can see in Victoria Harbour. Okay, next slide. How do we resolve this large rise from 1991 to about 1999? We are fortunate. On my right-hand side is the North Point Quarry Bay record. So this is based on a publication by Hong Kong Observatory. They also show another tide gauge in Hong Kong, Tai Po Cow, which is the one in Tidal Harbour, if you remember the constriction of the coastline. So both these are tide gauges in Hong Kong, and you can see the difference in the magnitude of rise during this 1991 to 1999. So we can actually correct the North Point Quarry Bay tide gauge data using Tai Po Cow. And up to 17 centimeter of the 26 centimeter sea level rise may be attributed to ground settlement, or 69%, quite a lot. So you can actually do correction if you have more information available. Now, what else can you do? Next slide. Now, we now, from 1993, have availability of satellite altimetry. The satellite passing above the Earth is sensitive enough to measure ocean surface changes. But this data is only available from 1993 onwards. And based on this data, we have a better picture over a larger area of the South China Sea. Next slide actually summarizes some of the information based on other people's work. Next slide, please. None of these are my work, but Hong Kong Observatory is Wong et al. So during different periods, there's been a fall of sea level, rise in sea level, and so on. So it's gone up and down at least a couple of times based on their work. and based on using satellite altimetry also, merge altimetry. Some are based on tide gauges. So you can see that the record is a little bit conflicting. We're not too sure what is really happening. And one conclusion is that our tide gauge is an anomaly. It doesn't fit in the rest of the world, which is quite interesting too. Next slide. Now, if you look in more detail about influence of rainfall, which should theoretically affect runoff into the South China Sea, surely this thing may matter. A lot of rainfall means lower pressure. Sea level may be elevated as a result of the low pressure that year. So I did this analysis looking at correlation coefficient between rainfall and sea level, and mean sea level. Not very strong, but 0.4 is something. So perhaps there's a connection with runoff from the region. We're at the mouth of a major delta with lots of runoff from the Pearl River Basin, and then the low pressure during wet years or dry years when you have high pressure. Do we have evidence to support that? Next slide. We do, I think. 1963, when we had the lowest rainfall on record from 1884, we do have a low point in sea level. 1997 was the wettest year on record. It's an ENSO year, El Nino Southern Oscillation year. And this is at least partially responsible for this accelerated sea level rise that you can see from 1991 to 1999. So at least part of these changes can be attributed to precipitation or pressure changes. Next slide. If we look at monthly variation of sea level, so by plotting the monthly mean sea level elevation at 3 tide gauges, Chimawan, North Point, Taipo Kao, you can see interesting things happening. It's monsoon driven. In the summertime, we have southwest monsoon, so the wind comes from the southwest. In the wintertime, we have northeast monsoon. So wind forcing becomes quite important. This is what I trying to say here. Monsoonal variability, coastal configuration, pressure and rainfall are being affected. And out of these 3 tide gauges, Taipo Kao, because of its coastal configuration, is at a maximum. Chimawan, I'll show you the map later so you can see it. It's intermediate. North Point, the one that Hong Kong Observatory is using for the projected sea level rise, is at a minimum. Next slide. So the 3 tide gauges, Taipo Kao is located here within Tolo Harbour. So maximum effect of the northeast winter monsoon when you have high pressure. So sea level is much more elevated because of the wind direction. It's coming from the northeast. Chimawan is also facing the northeast, so it's also relatively strong, but much less than Taipo Kao. But North Point Quarry Bay has the weakest forcing because the harbor is open on the eastern side as well as the western side. So wind and pressure has much less impact. The southwest summer monsoon is the low pressure, so it has elevated sea level. Okay, next slide. So global temperature anomalies, do they also affect cyclic changes? We have evidence of this. The Chinese calendar, I think for those who believe in it, has been very reliable in terms of predicting cold periods in the year. Every time Chinese New Year is always cooler. And this 60-year cycle is based on astronomical forcing, planetary alignment, for example, gravitation changes, and so on. So sometimes people call this the AMO, Atlantic Multi-Decadal Oscillation. Next slide, you can see it a bit better. So unfortunately, Hong Kong has a short record from 1955 to 2022. So all we can see, which seems to be in agreement with the record that we have in Victoria Harbour, seems to be in the direction of this arrow. We do not have long enough a record to go back to look at full 60-year cycles, or 62, or roughly 60-year cycles anyway. Okay, next slide. So what we need to do now is accurate surveying of these tide gauge location. This is something that we're trying to persuade the government to do, using INSA, this method of satellite surveying, to determine crustal changes. Hong Kong relies on lots of import, including reclaimed land, where we put sand and gravel for reclamation. So this obviously loaded up the crust and may cause the crust to sink. So we need evidence of the ground movement. Okay, next slide. Interestingly, if we look at the Macau record, which is even longer than Hong Kong, even though it is unfortunately also located on reclaimed land, there's evidence of seismic event which may have triggered some of the sea level changes. I've inserted 2 magnitude 6 event. In 1962, He Yun, which is northeast of Hong Kong, 150 kilometers. This is west of Hong Kong, Yangjiang, 6.4. And you can see, interestingly, the Macau tide gauge has recorded maybe some of these changes. We're not sure why. But with vibration from earthquakes on reclaimed land, on a muddy shelf, you would expect spontaneous liquefaction, quicksand effect. And this we suspect may be the connection. So it opens up a lot of questions to us. Well, if we just project the sea level rise like the Hong Kong Observatory, you're missing out on all these interesting things which may be happening. Okay, next slide. Okay, to sum up, again, some words are cut out. Controlling factors of sea levels in Hong Kong. I try to summarize most of these here in note form. Astronomy, cyclic changes in sea level, cycle length, and approximately 60 years, tracking the Atlantic multi-decadal oscillation. Second is tectonics, crustal instability through loading and unloading, tectonic movement, erosion, and deposition, including mass movement and sedimentation. Man-made, climate is the next one. Lowest uncorrelated mean sea level of 1.28 meters above chart datum in 1963, our driest year on record. And this driest year was caused by a volcanic eruption on Bali, Egong. Wind circulation change in the region, predominantly northeast monsoon forcing that year. So the possible influence, the wettest year on record is in 1997. Low local regional pressure and high Pearl River discharges. And then 1991 to 1999, when you have accelerated sea level rise of 26 centimeters, only at Loft Point and Quarry Bay, partially explained by cyclic climate change. So this may be one of the factors. And then man-made factors are the last two. Low relative sea level from 1985 to 1987. The uncertainty was introduced by the relocation of North Point Station to Quarry Bay. I think the observatory denies this, but I think this is one of the factors. Then isostasy-related sea level changes. Activities include coastal reclamation, construction loading, landfills, quarrying, and dredging. So we have lots of landfills in Hong Kong. They're running out of space. That shows you the extreme case of crustal loading. I think someone should do some calculation to work out. Next slide. So some of you have seen this slide before from a previous presentation, reminding us of the order of importance of climate change in driving sea level. First order is again astronomical forcing, including the cyclic changes. The sun, interglacial glacial cycles are true global climate change. I think the group INQUA, this group of people really knows about this. But now we are overtaken by other groups. They are responsible for monsoons, seasons, even daily temperatures. Midday sun is the warmest, right? This cannot be denied. Second order is what I spoke about before. Geothermal heat, including submarine volcanic eruptions and so on. And then third order includes other things humans may be doing, such as carbon dioxide and other greenhouse gases. Okay, next slide. Just in summary, before we look at Fort Denison, for some final words, we have now obtained a 500,000 year record of sea level change. They are caused by, representing 5 interglacial glacial cycles. They are generated by real global climate change have been identified. Uncertainties in the tide gauge record are caused by the location of tide gauge stations. So this is from North Point to Quarry Bay on reclaimed land, which are prone to ground settlement. The projected rate of sea level rise of 32 millimeter per decade of the Hong Kong Observatory is an overestimate because of a variety of local factors have not been taken into account. Up to 17 of the 29 centimeter accelerated sea level rise observed in the Quarry Bay tide gauge during 1987 to 1999 may be accounted for by ground settlement. Natural and man-made factors contributing to sea level change include sedimentation, crustal loading and unloading, neotectonics, so may be generated by crustal loading, rainfall and river runoff, wind forcing and pressure change. Storm surge flooding of low-lying land during storm typhoons is a past and present concern. I think we need another 50 years of observation assisted by INSA to confirm the cyclic changes. I think we have one final slide, which may be of interest. This is the Fort Denison record, which is more than 136 years old. We know that this is a reliable record. It's the best record we have in the Southern Hemisphere. However, the record shows the rising rate of sea level rise in Hong Kong is more than 3 times faster than Fort Denison. I would believe in Fort Denison, not Hong Kong. I think, as in the word of the late Bob Carter, there's no scary sea level rise as shown by the Fort Denison record. Thank you very much.